Hey, Science 30s, and welcome to the start of our final chapter here in the course. Today I'm going to be starting Chapter 2 of Unit D, Dreams of a Sustainable Future. You can find the information of this chapter on pages 522 to 557 of the textbook. Uh, don't really need the data booklet for this section, a pretty straightforward section. Just some memorization of different types of sustainable or renewable forms of energy and how they work and how they generate electricity. So pretty much now we are done the math component for the course. As you just finished up with our calculations last time on the E equals mc squared equation, that was pretty much the end of the math as we need to cover for this course. So let's delve into this unit right now, or this half of the unit, and we'll start with topic 2.1, which is describing sustainability. That's our name of our chapter, is a sustainable future. Well, what's sustainability? Well, again, from a definitional standpoint, it's the capacity of maintaining something at length without interruption or weakening indefinitely. So can we do something for long periods of time without there being some kind of a stoppage to what we're doing or a weakening of what we're doing? And we've kind of alluded to this earlier in the unit, how humans have sort of kind of our demands continue to seem to increase, and energy requirements seem to increase every year, every decade. Can we be smarter about how we're doing things with the use of energy? Can we be more efficient, or can we find forms of energy generation that are going to be more sustainable, that are going to be more long term than perhaps some of the short term non renewable resources that we are currently using? And that includes things like fossil fuels, and even to a certain degree nuclear energy and nuclear fission, because there is only so much plutonium and uranium on the planet. I mean, eventually we're going to run out of it. Right now, we only have to use small amounts of it at any given time, but to continually use them, is there a way that we can generate energy that we can continue to generate it over and over and over again? And I kind of alluded to that at the end of our topic 1.4 discussion, when I discussed the possibility of having a nuclear fusion as a form of energy at some point in the future. I mean, we're still a long way away from that, but that's sort of what we're looking at, is that kind of sustainability over the long haul. And again, in nature, things tend to be sustainable. Healthy ecosystems are sustainable. They can basically continue to run themselves. Materials are recycled through biogeochemical cycles. If you've taken my biology class, you know all about this in Bio 20. However, humans in the industrial age, we have primarily been a non-sustainable species because we are, again, overusing raw materials in the environment. We're using a lot of non-renewable sources of energy to generate energy creation. And eventually, we're going to exhaust the sources of raw materials and energy. So we need to look beyond what we're looking at right now. Are there other ways that we can do this that will be, again, more sustainable? When we're dealing with sustainability, there's all sorts of sustainability when it comes to humans. You've got to be looking at several factors. There's ecological sustainability, there's societal sustainability, there is economic sustainability. What do I mean by that? And could the government ask you questions about this? Yeah, they could. They could throw this stuff at you. They do like to ask questions about whether something is societal or economic or environmental. So what are some of the examples here? Ecological sustainability, well, protecting the biosphere, right? We're protecting ecosystems around the world. We're protecting biodiversity in those ecosystems. We're not killing organisms in order to do what we need to do to basically have our way with the planet. Can we do it without killing other species that are out there and eliminating them from existence? How about maybe not making pollution? We've had a big section of this course was about how humans are polluting the ecosystem with the creation of all sorts of products, whether it be acid deposition or organic chemicals that we're producing. Even in the case last day in my last video about ionizing radiation in the form of gamma radioactive decay, which would be a byproduct of nuclear fission reactions. Um, can we do things that are not contributing to depletion of the ozone? We've looked at that already with the Montreal Accords in 1987, but one of the big things that we still haven't got a grip on, we just can't seem to agree on it, is our production of greenhouse gases. And can we do something that's going to reduce our greenhouse gas emissions that are going to be healthier for the planet as a whole, preventing acidification of the oceans, climate change, all of these things that are associated with the increase of greenhouse gases in the atmosphere. So, societal sustainability, what are we dealing with there? Um, you know, are we able to not cause there to be decreases of life expectancy amongst humans? Or what we're doing, the pollution that we're creating, or the things that we're doing, is that potentially going to decrease life expectancy? These are things that we want to avoid. Reducing excessive land use, urban sprawl, the whole people moving out into the suburbs and using more and more and more land. Can we recycle areas of a city that have sort of kind of become older? Can we revitalize these parts of the city so that we're not just continually spreading out and then older, decaying infrastructure in the center of the cities? And we're seeing some of that in Edmonton. I mean, we have a long way to go in the Edmonton area, but there's certainly been revitalization projects in the downtown Edmonton core, and that continues to happen to kind of reutilize spaces that have maybe fallen into age and disrepair, rather than just heading. Another example would be the former Edmonton Municipal Airport. When they closed that down by Nate, they've been basically converting that into a giant housing development with park space. A beautiful area, very close to downtown Edmonton. That's sort of revitalizing, new community out there. That's hopefully going to bring some younger families in to closer to the urban core. What else can we do? Can we encourage per capita? Can we decrease per capita energy consumption? We've talked about that. How Canada has a fairly high energy intensity, and per person we're using a lot of energy to produce the dollars in our GDP. How about requiring cooperation of diverse cultural groups in decision making? A bit of a hot topic issue, but again, looking at when we're looking at, say, moving materials to the country right now, the big issue is pipelines. And again, I know that isn't renewable, but I mean that's the form of energy that we're using now. But consulting with indigenous peoples of Canada to make sure that they've had their say as well, not just every stakeholder should have their say in the country, not just the people that are proposing or making the pipeline. Everyone should have a say there. What about economic sustainability? And then we'll move on to the actual main point of today. How about supporting a full-time employment? Can we create employment with these forms of energy? Are we going to put people out of work because we don't want to have a form of energy that maybe puts people out of work for whatever reason? How about I guess a method of energy creation that's going to put people out of work? How about has a relatively low cost per megajoule? Again, can we make this a form of energy production relatively less energy intensive? Does it reduce the import and increases the export of energy? So can we maybe export our energy out to other countries and not us being reliant on other countries to basically help us with our energy needs? And does it not decrease the availability of natural resources? So can we keep our natural resources without having to actually remove them just for the sake of using it for energy creation? So these are all things that we have to look at if you're looking at sustainability in the creation of energy. And again, part of this whole sustainability of energy creation is to try to find ways to create energy that are using renewable resources. That's key to this. Breaking our, I don't want to say our shackles, but breaking our mindset that we can only use non-renewable resources to create the majority of our energy. Again, we've talked about how Alberta uses a lot of coal to generate electricity. Can we switch our mind and switch our thinking to perhaps find other ways that are going to be renewable sources of energy? And I've mentioned to you already in this course that a lot of forms of energy, some way or shape or form, are linked back to solar energy. We talked about how fossil fuels initially were created from solar energy because the plants that create the fossils or the animals that ate the plants that became fossils basically got their energy originally from the sun's energy, which was then converted into chemical energy via photosynthesis. So that was all forms of solar energy. And I am going to discuss the indirect solar energy. And then next day, which is our last topic on topic 2.2, pardon me, I'm going to discuss the forms of more direct solar energy that we can use that are definitely considered renewable because we're harnessing them almost directly from the sun or very close to directly from the sun. There are very few renewable resources or forms of energy, for that matter, that don't have a real direct connection to the sun. We talked about one last day. We talked about nuclear energy. Nuclear energy really is from strong nuclear forces that are creating those forms of energy. There are two other forms, and remember, I did mention that nuclear energy fission is a non-renewable form of energy creation. Fusion, if we could make it, would be a form of renewable energy. But there are two forms of renewable energies that I'd like to talk about today that don't directly connect to solar energy. These are energies that are created either through nuclear forces or nuclear radioactive decay, or we've got another form of energy creation that is created through gravitational force. So I'd like to discuss those two today before I discuss the remainder of the renewable resources in our final discussion of the course next day for 2.2. So the first of these two that I'd like to discuss is called geothermal. Geothermal is basically, it's a renewable source of energy that uses heat that originates from the Earth's core because of radioactive decay of elements that are there. For example, there would be elements like isotopes like potassium-40, thorium-232, uranium-235, uranium-238. These are all elements that are essentially radioactively decayed inside the Earth's core, and they are releasing energy and heat as a result. So we could basically, in areas where there's more, I guess, geologic or volcanic activity where there are vents that are actually connecting the depths of the Earth back to the surface. You have to have specific places on the Earth for this to happen. You can't just set up geothermal power plants anywhere on the planet. You have to have places where you essentially have like a lifeline or a connection point down into the depths of the Earth, and that usually involves areas that have higher than normal plate tectonic activity or potentially even volcanic activity. It's not necessarily directly related to having volcanoes in your backyard, but you're looking at areas that are maybe located along geothermal, plate tectonic plates is what I'm trying to say, around the Earth that are basically moving. So what would be some examples of countries that are using this type of energy right now? Iceland is a leader. Iceland is definitely a leader in geothermal energy. They've got lots of volcanoes and very active geology that's happening in Iceland. But there's a lot of other countries you wouldn't normally associate this with. New Zealand would be another one because they do have some volcanic activity and they have earthquakes, and they're close to several tectonic plates that are on the edge of the Pacific Ocean there. The Philippines are another one. Mexico is another country. Indonesia, Italy, United States, particularly California. What do these all have in common? They're all close to tectonic plates that are in motion. So you can't just set up a geothermal plant anywhere. You couldn't really set up a geothermal plant in Morinville. We don't have the geology for it here. But where you can set them up, they are initially expensive to set up. That is a disadvantage of them. You have to spend a lot of money to basically get the technology down. And you can see there's a diagram here of what it sort of looks like. If you've got your notes up, you can see that for yourself. But once they're up and running, they are literally next to nothing to run. So once you've got them established, they are very, very cheap to run, and pretty much you are making nothing but energy, and you're not having to spend a lot of money to do it. So your energy intensiveness to actually, and capital wise, the initial capital wise, you've got a lot of investment, but once you've got the thing rolling, it's a pretty easy economic um, kind of a plant to run. You don't have to have a lot of money to continue to run it, and there's a lot of profit after the initial setup. Drawbacks include, now when you open up cracks into the earth, you're not just going to get the heat from the earth, you're also going to get some other products that are being released by the earth, things like hydrogen sulfide, CO2, that originate from deep in the Earth's crust are going to basically be able to get out as well. These emissions, as you're well aware, hydrogen sulfide can lead to acid deposition, and CO2 obviously being a greenhouse gas, that's an issue as well to increase. So are there ways to perhaps capture these to prevent them from getting out? And that would be something that would have to be looked at as well. And again, it is only cost effective in areas where you've got geological hotspots. So if you're interested in learning more about geothermal energy, give this video a watch. It'll give you a little run through of how the actual plant runs from start to finish, give you some information about that and how it actually works to generate the electricity. But again, very similar to what we've talked about before, right? You're going to create the heat's going to boil water, the water is going to create steam, the steam's going to turn the turbines are going to basically cause kinetic energy to basically create a magnetic field within a generator, create an electromagnet, you get your electrical current that emanates from the electromagnetic field, and you basically create your electricity. So these are all, it's just how do we get the turbines to turn? That's basically, each of these methods of renewable energy we're dealing with all have to find a way to create motion or kinetic energy in a turbine to basically then connect into an electrical generator, which can then generate the electricity. That's what they all have in common. But it's just how they create that kinetic energy in the turbine, which is going to change, right? But they're all generally doing it by some form of heat, or in some cases it is direct motion. If you have, let's say, wind power, hydroelectric power, you're not dealing with heat there. You're dealing with a turbine, the windmills that are turning, or turbines that are turning because of water that are moving over them. But in a lot of cases, like geothermal, you're dealing with the heat that's creating the turbine motion. All right. Again, another diagram of how geothermal power plant would work gives you kind of a breakdown of what it looks like. You can see there we've got our turbine, our generator, we've got our transformers that are going to basically then convert the electricity that's coming out to a high voltage. We talked about how high voltage with a low current is going to reduce the amount of electricity lost in transmission. So we use a step-up transformer to step up the voltage, and then when that voltage gets to your neighborhood, you're going to then use your step-down transformers to basically lower the voltage and increase the current at that point. So there you go. One last one to finish up today's topic. The second one that doesn't really have any direct relation to solar energy is tidal. Tidal energy is kind of a cool one. Again, can't really use it here in Morinville, but areas where you get along the coasts of countries, there are some very interesting tides that can actually happen. If you've been out to the eastern part of the country, to the Maritimes, you may have been out to the Bay of Fundy. Bay of Fundy is actually using this technology because Bay of Fundy has the highest tides on average per day. So basically the tides run twice daily and they rise and fall because of the sea levels there. And why does this occur? Well, why do we have tides at all? Well, tides are based on the gravitational pull, the pull of the moon on the earth, and also the sun. The sun does have a gravitational pull on the earth as well. So basically, the moon, depending on where it is in relation to the earth, is going to pull water toward it, and basically that's going to create your higher tides, and then you basically have that cycle that runs through twice a day. One thing that you should be familiar with, and this diagram is really good at explaining it, so if you've got the notes, I'll pull them up. This is a question that's come up on quite a few exams that I've seen, diplomas it's been on before. They're asking you to know when the tides are going to be the most extreme, because tides do change over the course of a month. You don't have the exact same tides. There are some times of the month when the tides are stronger or higher, or there's bigger fluctuations between the tides than in other parts of the month. When does this occur? Well, generally speaking, the highest tides occur at either a full or a new moon. And the reason for that is, in order for the tide to maximize, you want the moon and the sun to be lined up in a straight line along the earth. So right here, the moon is between the sun and the earth, so that would be a new moon. If that moon was over on this side of the Earth over here, it would be facing toward the sun and we would have a full moon. But because we've got the sun and the moon lined up on either one side of the Earth or on both sides of the Earth, that's going to pull the water the most. If the moon is at a quarter or a half moon, if the moon is at a half moon where the moon is at a 90-degree angle relative to the sun, there's my 90-degree angle, that's when your tides are going to be the lowest during the month. So just keep that in mind that based on where the moon is at any given time uh, of the month, as the moon goes from a new moon to a half moon to new moon goes to a waxing moon, which becomes a half moon. The half moon then becomes the full moon. Then the full moon begins to get smaller, becomes a half moon again. It goes into its waning phase, and then it goes all the way back to a new moon. But generally speaking, new moon, full moon. So here's my Earth. Here's the Earth right here in the middle. They're on this side of the Earth, and then here the sun would be like over here somewhere. If they're all in a row to each other, if they're all in a straight line, the sun, the Earth, and the moon, that's when you've got your biggest tides. If the moon and the sun are sort of at 90-degree, here's my Earth, here's the sun, my one finger, here's the moon. If they're at 90-degree angles relative to the Earth, then that's when you're going to have your smallest tides. But regardless of whether you have the highest or the lowest tides, tides are very much a renewable resource. They happen every day. They happen twice a day. You get the tides move out, the tides move in. You get the cycle twice a day, and this is where the water can rush into tidal basins. And we can use that movement of water to basically run turbines. So it's kind of like hydroelectricity because you've got water running over turbines, but these turbines are now found under the ocean, somewhere close to land, where you've got these high tidal fluctuations. So regardless if the water is flowing in or out, if the water flows through these turbines, it's going to create the kinetic energy, which is going to create the motion in the generators, to create the magnetic fields, which will then create the electricity. And that electricity can be sent out, step-up transformers, off for transmission, and off to where they need to go to power homes or businesses. What are some of the advantages of tidal power? Well, tidal power, they do not create any emissions at all. It's emissions-free. They require no fuel source whatsoever. There's absolutely no fuel source required for this. And they have very little effect on the marine ecosystem if they are put in properly. If they're put in with special guards, we don't want to have any obviously underwater organisms being swept into turbines underwater. So there's all sorts of safeguards that are put in place in front of these turbines or these underwater windmills or whatever you want to call them that are under the water that are not going to allow organisms to get swept into them. Disadvantages: they generate electricity in rather small amounts. So compared to, say, forms like solar energy, and you're getting massive peaks at certain times of the day where you're producing lots of electricity relative to other parts of the day. When the tides aren't coming in or going out, you have big sections of time where the power production or the energy production, is going to be much lower than at other parts of the day. So that is a problem. And as I mentioned, probably the best place in Canada for them right now is the Bay of Fundy. If you're interested a little bit more about learning more about tidal power, take a watch of this video. It's a great one to watch, and it definitely gives you some ideas as to how it actually works out there, especially here in the Bay of Fundy, which is kind of in our own backyard. Not really, but it's in Canada, so technically all of Canada is in our backyard, right? Here's a diagram of how it works. Here's basically the water moves in past the turbine. There's that turbine there in the middle. The turbine again turns, and it turns the generator module, which produces electricity. The turning turbine will then create the kinetic energy in the generator to generate an electromagnetic field within the permanent magnet of the generator, and then that electricity can then be shipped out to businesses and homes everywhere it needs to go. There you go. That's our topic for 2.1. Homework today, really small homework today. You guys got it so easy today. It's going to be questions 1 to 3 on page 535. Not a whole lot of homework today's section of notes. Thanks for tuning in, and won't you join me next time when I discuss topic 2.2, which are the many forms of solar energy. We are going to wrap up Science 30 in style. talking about that all important solar energy. Thanks for tuning in, everybody, and we will see you again one last time for section 2.2. See you soon.